Introduction. The many facets of civil engineering are represented by the fields of structural engineering, transportation and geotechnical engineering, hydraulic and hydrology engineering, and environmental engineering. These specialized departments work together in this vast field to plan, construct, and oversee the natural and man-made features that shape our environment. These fields work together to create the foundation of civil engineering, creating sustainable and useful infrastructure. These engineering specialties come together in this straightforward but crucial convergence to help create sustainable and environmentally friendly solutions for a world that is changing quickly. These are the content that includes in our video: structural engineering, transportation and geotechnical engineering, hydraulics engineering, hydrology and environmental engineering, and lastly, bonus question. This project is completed by our team, that is Aidin bin Muhammad Yazid, Muhammad Hafiz Muaz bin Hamdan, Kia Yik Hao, Loh Yin Sweet, Sharifah Nur Afrika binti Abdul Rizal, and Nur Iwani binti Basuk Muhammad Fauzan. The objective of this video is to explain and discuss the subfields of civil engineering, summarize all 4 subfields of civil engineering, and lastly, to answer the bonus question in the video.
Hi, my name is Nur Iwani and I will talk about structural engineering. What is structural engineering? Structural design is a highly specialized field of civil engineering, one of the oldest engineering disciplines. While civil deals with design elements as well as their construction, structural design focuses more on evaluating and inspecting the materials for the construction and ensuring that they can support the design set by the civil engineer and architects. Structural design combines the fundamental principles of physics with material science in finding, discovering, developing, and using materials that will be able to withstand the forces that the structure will encounter during its service or usage. What does structural engineers do? First of all, design structures. Structural engineers help design and build structures, beautiful structures, useful structures, and sometimes simply modern structures from bridges, roller coasters and skyscrapers to hospital, homes and public artworks. Second, ensuring safety standards. Safety and quality work are major priorities for structural engineers. To ensure safe design, engineers and designers follow the latest codes and standards in their structural design, perform their design checks and sign off on checklists prior to finalizing the design. Third of all, analyze structural integrity. Structural analysis is calculating and analyzing the effects of loads and forces on physical structures and their components. Aside from buildings, bridges, canals and roads, forms of transportation such as aircraft and ships are also subjected to structural analysis. Lastly, inspecting existing structures. Engineers perform comprehensive site inspection of existing structures, structural components and access system of being inspected thoroughly to determine signs of deterioration, defects or damage. Types of structural engineering jobs. First, building structures, earthquake engineering structures, mechanical structures and aerospace structures. Then I will summarize our assignment about structural engineering, which is Menara Telecom. The Menara Telecom or Telecom Tower is a skyscraper located along the Federal Highway, Sprint Expressway and Jalan Pantai Baharu and is served by the Rapid KL Kerinci LRT station in Selangor, Malaysia. It is the largest telecommunication company in Malaysia and second largest in Southeast Asia, placed 170 on global ranking and 6th tallest skyscraper in Malaysia. The building was officially opened on 11 February 2003 by Tun Dr. Mahathir Mohamad, the 4th Malaysian Prime Minister. Menara Telecom was designed by Hijaz Kasturi. The design of Menara Telecom is derived from bamboo shoot, which represents strength and growth. The bamboo shoot shape and symbol can be seen from the plan and elevation section of it. It gives different views of visual forms, ranging in height, width and slimness depending on the viewer's perspective from the street. For instance, Menara Telecom looks wider and the full breadth of it is apparent when it views from north to south, while Menara Telecom looks narrow and taller when it views from east to west. Lastly, the structural system of Menara Telecom is it have core and foundation of the building, truss system and spider glass clamp and wind tunnel. And the selective structural element is it have bowing string tissues, beam and column.
Geotechnical and transportation in tropical climate. What is tropical climate? A tropical climate is identified as a climate characteristic to the tropics. That is from the equator to the Tropic of Capricorn in the south and from the equator to the Tropic of Cancer in the north. The Köppen climate classification defines a tropical climate as a non-arid climate in which the mean temperature is about 64 Fahrenheit. Throughout the year, the core defining trait of a tropical climate is the warm temperature. Geological engineering is concerned about application of geological science and principle of fields, environmental and forestry, regarding changes such as earthquake, rising of water sea level and shrinkage problem. Geotechnical engineering is the specialist branch of civil engineering concerned with the behavior of earth materials and the application of soil and rock mechanics. Geotechnical engineers determine the physical, mechanical and chemical properties of soil and rock to design foundations, retaining structures and earthworks. A geotechnical site investigation determines the engineering parameters of soil and rock and how they will interact with the proposed construction. The aim of ground investigation is to assess the geotechnical, geological and hydrological risks to human, property and environment. How can geotechnical relate to tropical climate? Geotechnical is a branch where we study the behavior of earth materials like soil and rock. Soil is a very important component in engineering. When there is a tropical climate, thus it will affect the properties of soil. When temperature increase, the soil will be drying. Soil shrinkage and soil erosion can when the mean precipitation increase. The quality of soil will decrease and the change in water table leading to instability. Transportation engineering is a relatively new subject under the field of civil engineering and covers aspects of the highway engineering, traffic engineering, transportation and travelling in general. Tropical climate is likely to damage transportation infrastructure through higher temperatures, more severe storms and flooding, and higher storm surges, affecting the reliability and capacity of transportation systems.
Hi, my name is Tia Hao. I will explain about the hydrology and environmental engineering. Firstly, hydrology will study of the water on Earth. Water exists in solid, liquid, and vapor, adapting to change in temperature and pressure. Water originates from natural processes like evaporation, precipitation, and runoff, ultimately returning to ocean, river, and groundwater. Water's availability, distribution, and utilization are vital considerations for sustainable resource management. Water's chemical composition, H2O, and physical properties like surface tension and thermal conductivity underpin its unique characteristics. Water interaction with physical, biology, and human environment. Here are some example applications of hydrology. For example, designing and operating water supplies for industry require tailored systems for efficient use. Ensuring the quantity and quality of drinking water is essential for public health. The hydraulic structure like dams, irrigation facility, and bridges are crucial for managing water resources. The second topic is environmental engineer. Environmental engineers are the technical professionals who identify and design solutions for environmental problems. They provide safe drinking water, treat and properly dispose of waste, maintain air quality, prevent and control water pollution, and remediate contaminated sites. Environmental engineers monitor the quality of air, water, and land, and they develop new and improved means to protect the environment. What the environment engineer do? The environment engineer will supply water, manage the environmental and water quality, control the air and noise pollution, and more importantly, this diagram explains the evaporation of water from the sea or lake to the condensation of cloud. When the condensation process reaches a certain rate, the precipitation process will proceed. This process keeps repeating, so it called the water cycle. Another picture I take from Google also explains the water cycle. That's all for me. Thank you.
Assalamualaikum and hi everyone. I will present about water resources and hydraulics. So what is water resources? Water resources is quantitative study of the hydrological cycle, the distribution and circulation of water linking the earth, atmosphere, land and ocean. Hydraulic consists of the application of fluid mechanics and hydraulics to water flowing in pipe, pump, stream and ocean. So for section A, we pick question about climate change. So climate change causes by human activities including burning fossil fuels and deforestation release greenhouse gases like carbon dioxide into the atmosphere. So next, the solar radiation from the sun can influence climate by affecting the amount of sunlight absorbed by the Earth's surface. And lastly, volcanic eruption release gases and ash, including sulfur dioxide, which can lead to short-term cooling by reflecting sunlight back into spaces. So this is the detail about the climate change. So next is what is SDG? SDG is Sustainable Development Goals that has 17 goals to end poverty and other human programs. So SDG that relate with climate change. So the first one is SDG 13, combating climate change. Next one is SDG 6, ensuring water access. And lastly is SDG 14, conserving oceans. Urgent actions involve sustainable water use, reducing greenhouse gases emission, and enhancing resilience to climate change effect. Individuals, communities, and government must take sustainable choices to reduce emission and protect the environment. So for the section B, we use the tsunami question. So what is tsunami? Tsunami are large wave caused by underwater disturbance like earthquake, volcanic eruption, or submarine landslide. Initial disturbance generate primary wave moving rapidly across the ocean with low amplitudes. As the wave reach shallower coastal area, their speed decreases but their amplitude increase, causing a sudden and potentially destructive rise in water level. Tsunami energy originates from underwater events, often earthquake on the ocean floor, releasing massive energy that displaces water and raises sea level. Gravity then pulls the elevated water down, creating horizontal ripples that propagate as tsunamis across the ocean. This process can lead to significant inundation, posing a threat to coastal communities. So how does tsunami occur? Tsunami occurs firstly an earthquake rock the ocean floor, then displaces volume of water, pushing it up, set off an oscillation which develops underwater at great speed, and then seawater is sucked back from the shore, and then waves grow in size as depth becomes shallower. So process shallowing when tsunami. Shallowing is the increase in wave amplitude when water waves transition from deep to shallow areas, especially near the coast. The danger of tsunami wave intensify as they approach the coast with their height growing larger in shallower water. This phenomenon occurs due to the force from the seabed as it becomes shallower, slowing down the wave. In coastal regions, the shallower the water, the slower the wave, making this as a crucial factor in wave dynamics. So, in summary, human activities such as burning fossil fuels and deforestation contributes significantly to climate change by releasing greenhouse gases. Natural factors like solar radiation and volcanic activity also play a role but have a relatively minor impact. The consequences of climate change include the water cycle leading to extreme water events, rising sea levels, and threats to coastal areas. This impact align with the United Nations Sustainable Development Goals, emphasizing the need for urgent action to combat climate change, ensure sustainable water management, and protect ecosystems. Additionally, understanding the dynamic of tsunamis and wave shallowing is crucial for addressing the risks they pose to coastal communities. Overall, collective efforts are essential to reduce greenhouse gas emissions, promote sustainable practice, and create a healthier and more resilient planet. That's it from me. Thank you.
Now the bonus question. I will give two problems, and that is urban heat island effects, that is arise when dense population of buildings, pavement and other heat absorbing surface replace the natural land cover of an urban area. Second is urbanization and infrastructure demands. In cities like Kuala Lumpur in particular, rapid urbanization poses problems for transportation congestion, infrastructure demand management, and sustainable urban development. The solution to urban heat island effects. First, green infrastructure. By adding green infrastructure projects like parks, green roof, and permeable surface can help lessen the impact of urban heat island. Cool roofs and pavement. Encourage the use of cool pavement and roofing materials that reflect more light and retain less heat. Third, urban planning and design. Incorporate sustainable techniques into urban planning and design, taking into account the effects of regional microclimates. Climate responsive architecture. Promote the creation of climate responsive building plans that use passive cooling techniques like thermal mass, natural ventilation, and sensible building orientations. Next, solution to urbanization and infrastructure demands. First, comprehensive urban planning. Create and carry out urban plans that prioritize zoning, green spaces, and future growth while taking infrastructure requirements. Second, investment in public transportation. Give funding for long-term public transportation system such as mass transit and pedestrian-friendly infrastructure. Third, infrastructure resilience planning. Develop resilient infrastructure to withstand climate change impacts, incorporating elevation in flood-prone areas. Lastly, smart city initiative. Adopt smart technologies to provide effective urban services. Pay particular attention to digital infrastructure, smart grids, and intelligent transit system. That's all from us. Thank you.
As a conclusion, through the 4 assignments we have discussed throughout the video, we have been exposed to new things in civil engineering that can enhance our learning minds and generate more creative ideas to solve engineering problems. All these subfields work together to make successful civil engineering projects happen, as they have their own specialization and they work together. That is all from us, Group 6 from Section 3. Thank you for watching and have a nice day.